Hello, welcome to Geometric Virtual Learning. We welcome all new viewers to this channel. We thank those who've already subscribed to this channel. If you are new to this channel, if you've not subscribed, please subscribe to this channel and share with your friends and like this channel. Subscribe, share with your friends, and hit the notification button so you'll be alerted to all the videos that I post. Thank you very much. This is the third lesson on transformation. We've already talked in lesson 1 on reflection, lesson 2 translation, and lesson 3 is enlargement. We will learn how to enlarge shape by a given scale factor from a given center, and also how to describe shapes when it's enlarged using the right word. How do you describe enlargement? Now, try and say, pause this video, and if you can draw a triangle that is twice as big as triangle A anywhere in the diagram. Okay, let's check. To do that, all you need to do is to double each side. Twice means double. So each side, you double each side. This side is 2, you make it 4. This side is 3, you make it 6, and so on. So this is what it's going to look like. Now the enlargement we're going to do is different from this kind of enlargement. We're going to talk about when you have a center. So the center will actually force the image to be in a particular place, no other place. So the center is very important. It helps you to decide exact place that it's supposed to be. And I'm going to explain to you the steps to do that. Let's start with a simple example to enlarge this triangle by a scale factor 2 from the center 0. What I need you to remember is that when you are doing enlargement, always the image, which is the enlarged shape, will not be congruent to the object. The only time that's going to be congruent to the object is when you have scale factor 1 or scale factor -1, which hardly comes in an exam. But if it does, you must know that when you finish doing enlargement, it should look just as the original one. It's going to be congruent. Apart from 1 and -1 scale factor, all other transformation enlargement will produce non-congruent shape to the object or the original shape. Okay, what are the steps in enlarging shapes from a center? First, locate your center. Second, draw straight lines from the center to all the corners or the vertices of the shapes. Now, each line that you've drawn, double it. That's what it means. So this for center, I'm going to draw a straight line from the center to each of the corners or the vertices. Then each line that I've drawn, I'm going to double it because it says scale factor 2. How do I do that? Let's start. My first point, this is how long it is from the center. Some people prefer to use ruler to measure and double it. So you can also use the slope of the line to decide. It's 1 across, 3 up. Continue. 1 across, 3 up. That will be the end of the line. Next, one across, double it. Next, we're going to double this line to understand this. 3 across, 1 down. Continue. 3 across, 1 down. Then at the end, join the end of the lines, and that becomes the image or the enlarged shape. That's it. To check that you've got it correct, compare corresponding sides and see what happens. This side is 2 squares. This side is what? 4 squares. And it confirms that 2 scale factor 2 means double. It's done. Let's look at the situation where we have scale factor 3. What happens to that? The same principle from the center to each of the vertices or the corners. Because it says scale factor 3, make each line 3 times as long. So the scale factor, that will be one diagonal. Make it 3 times as long. So it's 1, 2, and 3. Second point, here you could see it's 1 and 2. Continue. 1 and 2. 1 and 2. You repeat the same pattern 3 times because it's scale factor 3. 1, 2, 1, 2, 1, 2. 1 diagonal, so it's 1, 2, 3. Join the end of those lines, you got your image or the enlarged shape. Done. Double check if you are right. Corresponding sides. This side is 3, this side is 1. Confirms that. Now, what happens when you have a scale factor which is a fraction? How do we do that? Let's see. So we have a positive scale factor, but this time it's a fraction. Enlarge the triangle by scale factor half from the center 0, 0. The principle doesn't change. From the center, straight lines to all the corners or the vertices. Each line that you've drawn, this time half each of the lines because the scale factor is half. So we start. That's 2 diagonals away. Now divide 2 by 1. Divide 2 by 2. That will give you 1 because you're going to half it. So half the line. That's half of the line. This line, if you want to know how to half it, is 6 across, 2 down. So that will be 3 across and 1 down. You can really spot the half of the line easily. This line is 2 and 4. So that will be 1 and 2. You can see the half of the line. Join the end of the blue lines. So you see, it's still not congruent. It's smaller than the original. The reason because scale factor is what? Less than 1. So that's one thing you need to notice. Scale factor less than 1 will produce a shape smaller than the original. So the image here is smaller than the object because scale factor is half. So we've now talked about positive scale factor when it's a whole number. We talk about positive scale factor when it's a fraction. Now let's see what happens when you have a negative whole number scale factor. What happens to that? So for example, we're going to talk about enlargement by scale factor -2 from center 2, 2. The principle of starting with the center doesn't change. So start with the center, straight lines to all the corners or the vertices. But instead of doubling each of the line, we're still going to double each of the lines, but on the opposite side of the center. That's the difference. You're going to double it on the opposite side. Let's see how to do that. Center 2, 2. Our first corner is 1 diagonal away. So we're going to double this 1 diagonal, which will be 2 diagonal. We're going to be the opposite side. Do it on the opposite side. That's what I mean by opposite side. Instead of doing it this way, no, you're going to do it opposite side. Why? Because it says a negative. You're going to reverse it. Next point, we're going to double this line the opposite way. Double the opposite way. Last point, we're going to double this line the opposite way. 1, 2. Now join. Now you see it's still twice as big, but you can see that there has been a bit of flipping in there. It's still not congruent because it's twice as big. As you can see, 2 here, 4 here, but it's been flipped around because you flip it up and flip it to the left. So this is what negative scale factor does. It flips the shape. So whenever you see any enlargement and it shows clearly it's an enlargement, but there has been a flipping thing going on somewhere, remember it's a negative scale factor. That's a clue you need to remember. Negative scale factor will always flip the shape around. It's no rotation, it's a flip. It's no rotation. So here you could see it's like flipping this upwards and flipping this to the left. That's what this means. Now let's look at scale factor, which is negative and a fraction. Same principle from the center, lines to the corners. Each line you're going to half it. But each line, when you half it, you're going to do the half on the other side of the center, opposite side. So we start. This is 2 squares down. So you're going to do 1 square the opposite way. That is 2 diagonals. You're going to do 1 diagonal the opposite way. 2 diagonals, do 1 diagonal the opposite way. So also, the image is smaller than the object, but it's been flipped around. So it's half the size, but it's been flipped. So remember, negative scale factor involves flipping. The magnitude of the scale factor tells you the size. That's one thing to remember. So far we talked about enlargement, both positive and negative, whole number, negative, and we also have fractions, enlargement as well, both negative and positive. Now, how do you describe enlargement? Here, the order is very important. Described as a single transformation that maps triangle A to B. So it's A to B. The order is very important. 3 things needs to be said when describing enlargement. 1 is the name of the transformation, which is enlargement in this case. 2nd is the center of enlargement. And 3rd is the scale factor. You need to see all the 3 to get the full mark. The name of the transformation, which is enlargement, the center of enlargement, and the scale factor. Now, to find the center of enlargement, you need 2 pairs of corresponding sides, corresponding corners or vertices. 2 pairs of corresponding corners or vertices. Join each pair with a straight line. Wherever those 2 lines meet becomes the center. What do I mean by this? Let's see. That's my first pair of corresponding vertices. I'll join with a straight line. Straight line should be cutting across the point because the center could be up or down the graph. So you need to go all the way up and down. I need another pair of corresponding vertices. Join with a straight line. Wow, now I've got my center. So my center now is 5, 6. That's the center done. Now all I need is my scale factor. This is where I need to be careful here. The order A to B. This is the image and this is the object. A to B. To find the scale factor, divide the image by the object. So pick a side of the image and divide by the corresponding side on the object. That answer gives you the scale factor. So that's why I highlighted with green line. That's where I'm going to use to compare. Image is 4. Object is 2. 4 divided by 2 is 2. So I now know my scale factor as 2. My center as 5, 6. The enlargement is known. So in a sentence form, A to B is an enlargement by scale factor 2, and the center is 5, 6. Full mark. A to B is an enlargement by scale factor 2, center 5, 6. Let's look at another example. Describe transformation that maps shape A to B. A to B. First corresponding pair of corners. Second pair of corners. Now I've got my center. Center is 1, 5. To get my scale factor, object is A, image is B. Divide image by the object. Image is 1, object is 2. 1 divided by 2 or 1 over 2 is a half. So my scale factor here is a half. So A to B is an enlargement by scale factor half, center 1, 5. And it makes sense. From A to B, you could see that B is smaller than A, so something happened to cause A to become smaller and has to be a scale factor less than 1. So it makes sense. You need to apply a bit of thinking in your answers and you always get it right. Let's look at one final description. Okay, here before you start, remember this is not reflection, because reflection will produce congruent shape. This is not congruent, so therefore it nullifies to become reflection. The first thing is, okay, it's bigger, so it's an enlargement. And remember, there has been a bit of flipping. So you need to remember, well, like we said before, flipping, enlargement involves negative scale factor. So that's something that you need to remember. Let's start with a pair of corresponding corners. You need to be careful with your points. Another pair. Okay, since this particular shape has more vertices, let's join one more pair. Okay, so that confirms it. Our center is 1, 1. Okay, it's A to B, image, object. Divide image by object. Image, 1, 2, 3, 4, 5, 6. Image is 6. 6 divided by 3 is 2. Okay, but you cannot just say the answer, the scale factor is 2, because you remember there's a flip involved in enlargement. So the 2 has to be a negative 2. The negative causes the flipping. So we can say that our center is 1, 1. It's an enlargement, a negative scale factor 2. So that will be A to B is an enlargement by scale factor negative 2. And the center is 1, 1. So just to recap, remember, negative scale factor will always cause a bit of flipping in your image. The value or absolute value of the number will cause the size of the image. When scale factor is less than 1, you produce a shape that is smaller than the object. When scale factor is more than 1, you produce the image that is bigger than the object. So these are rules that you need to remember. They guide you as you work your way through enlargement. Thank you very much for watching, and subscribe to this channel, and look forward to the final lesson on transformation, which is going to be on rotation. Thank you very much.